Okay, we're going to do two little lessons this week on unit conversions. This is most directly for the Math 052 students, section 4.1, and the Math 038 students, section B4. The Math 02 students, you do have the metric system introduced, and they just talk ever so briefly about the imperial system. But you do some basic conversions. So the metric lesson would probably be more useful. That's going to be lesson number 2. This is lesson number 1. And Math 053, as I was just discussing with those in class, if you are feeling like you're not up on being able to do unit conversions, depending on what program you're going to go into, especially the sciences, it is something that you will have to do regularly on a regular basis. So it might be a useful little refresher for some of the 053 students. Very quickly, in terms of the other stuff in chapter 4 for 052, we've actually already covered it, because in our equation lessons, which went through all of the Math 053 equation chapter, that also included all the stuff with formulas. So there's 2 lessons in there called Working with Formulas 1 and Working with Formulas 2 that cover pretty well the rest of your chapter 4, and also cover a number of sections in Math 038. So if you want videos for those, you can let me know if you weren't in class for those. Okay, so the imperial system of measurement comes from Britain originally. It includes units to measure length, volume, and weight, and they mostly come from everyday objects and the human body. So this developed over centuries and centuries and centuries. So imperial ways to measure length. An inch, you know what an inch is, probably most of you. Well, actually, the inch came from being roughly the width of your thumb. And a foot is about the length of an average adult foot. A yard, a bit of argument whether or not this is the original meaning of yard, but it came to be understood as about how long a step is when you're walking at a pretty good pace, a stride. And mile actually came from the Romans, and what's the technical definition? It was the number of times that one of your feet would touch the ground. Sorry, the distance you would go when one of your feet touched the ground 1,000 times while you were walking. In other words, 2,000 steps, because each foot is going, right? Eventually, the British ended up changing that 2,000 to 1,760, because imperial units are weird that way, weird numbers. Imperial measures of weight. A pound was actually originally used for money, which it still is today in England. So a pound as a weight was how much the amount of silver that was worth a pound of money, how heavy that was. An ounce is Latin, and it means a 1/12. So originally, an ounce was 1/12 of a pound, but again, they changed it later and they made it 1/16 of a pound. Who knows why? A stone, you may or may not have heard, but if you go to Britain and people talk about their weight, they will still often refer to how many stone they are. The original meaning of stone was literally a rock, kind of the size of the guy that is holding it there in the picture has. Pretty heavy rock, but still one that you could lift comfortably. On to volume, the imperial units for volume. A cup, not surprisingly, is the amount of liquid that you would have in the average drinking cup that you had around the house. These are, again, the original meanings. Pint actually comes from painted, and if you had a bigger container, people would paint a line on it as a measurement. So it had no set amount originally, but again, eventually came to be standardized. A gallon was about how much water you could pour into a bucket. Teaspoon and tablespoon were the average household small spoon and big spoon. And a fluid ounce, we just talked about ounces as a weight. A fluid ounce was how much space was occupied by one weight ounce of water. Now, you don't need to know any of these things. Maybe I should have said that at that, but I find it's kind of interesting for people to see where these all came from. What becomes really clear is that there was tons of inconsistency with these measurements, because everybody's thumb, foot, stride. Everybody's cups and spoons in their house were different. Every time you picked up a rock, it was a different rock. There was no real consistency, right? These were approximations. But over time, they were all standardized with a specific rock that was then became, this is how much a stone weighs, this rock right here, a specific cup, a specific spoon, and then these measurement devices would be distributed so that everyone was using the same measurements. A specific person's foot was most likely, the king at a certain time who said, okay, we're now going to use my foot as the foot, and that's what everyone uses. Here's a stick that's the length of my foot. Pass these around. Or a ruler, I guess we would call that. I wonder if that's why it's called a ruler. I have to look that up afterwards. Okay. The relationships between the units was also standardized, so 12 inches in a foot, 16 tablespoons in a cup, and so on. You can see the numbers are ugly and inconsistent, which is why most of the world has switched to metric. Here is some imperial unit conversions, and you actually have a formula sheet I will make sure to get to you that has even more than the ones listed here, but these are the ones we'll use for this lesson. They show you, again, 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, 16 ounces in a pound, and so on. 8 fluid ounces in a cup, 4 quarts in a gallon. And we got some time going on down there as well. Okay, so you're allowed to have the formula sheet with all the conversions for your tests, and I have emailed it to you. I will have emailed it to you at some point soon. And you can print it out if you don't have access to your own printer. The help centers would be able to get one into your hands. Maybe check with me first and I'll let them know you're coming. So most of the world has switched over to the metric system, which is what we'll look at in our next lesson, because it is way, way simpler and it's way more useful for the sciences in particular. The USA and Britain are, I believe, the only two countries still using imperial units, though even their scientists refuse. Their scientists always work in metric. Scientists all over the world using metric only. But what do I say? Tradition is hard to change. Yeah. So what has happened is that for certain occupations and certain daily tasks, it's just sort of ingrained in our culture, and we still tend to use imperial units. So in construction, they're usually working in feet and inches, plumbing as well. Some auto mechanic stuff has switched metric, some has stuck imperial, which is even more confusing. When you're cooking, you probably are using cups and teaspoons and tablespoons as often as you're using milliliters, or maybe more often you're using cups, so imperial measurements. When we talk about our height and our weight, we usually say, I'm 5'10" and I'm 140 pounds. That's very inaccurate for me, by the way. That was somebody else talking. So we still often talk in imperial, even though we are technically on metric. So these things tend to come up. We're going to look at two different methods for doing unit conversions, and I wouldn't suggest necessarily that you learn both. I would suggest that that you pick the one that you like the best. So the method one is going to use ratios, which we just did a bunch of lessons on, and if you're in Math 052, you did in Chapter 3. So you might like that because it's something you're familiar with. The second one is a bit simpler once you catch on to it. So I'm going to show it to you because it does have certain situations where it's very much easier. In most situations, it's about the same. And then, I'm going to talk about 3 different methods, sorry. There's some students who, at least on the easier ones, they just look at it and they're like, yeah, I can just tell. I can tell that I would multiply for this one and I would divide for that one. And if that is making sense for you, great. What I find is a lot of students, the majority of students, don't feel that way about all the unit conversions. They get a little uncertain. Oh, is this a multiplying one or dividing one? In which case, methods 1 and 2 really help them out. Okay, I'm not going to go through all this, I don't think. I've just listed there what different people might find more convenient about method 1 or method 2. So here's the ratio method. We're going to convert 45 inches into feet. So there is our conversion. I've copied and pasted from the formula sheet that I showed earlier on, and you can see on there that 1 foot is equal to 12 inches. So some of you might see whether you multiply or divide here, but let's do the ratio method, because then you can apply it to any situation. So on the left side, you want to put the ratio from your formula sheet, 1 foot to 12 inches, because those are the same. On the right side, put the ratio you're converting. So 45 inches over on the right, because it matches 12 inches on the left, and how many feet. And what I want you to see there is that on the left side of each ratio is the feet, and on the right side is the inches. You could also have reversed that, as long as you're consistent. So whatever is on the left stays on the left, whatever is on the right stays on the right. So we have feet to inches on the left and feet to inches on the right, including our known amount of inches and the amount of feet that we want to calculate. Now you know how to do this, so I'm going to breeze through the rest. You turn them into fractions. You identify the pair that doesn't have a variable in it and the leftover one down there. You multiply the pair and divide by the other one. 1 times 45 divided by 12, and you get 3.75. So 45 inches is equal to 3.75 feet. The hard work was setting up the ratio, and then once you do that, fly through the solvent. And again, like I said, if you right away saw that you're going to divide by 12, that's great. I would suggest that when we get into some of the later ones, there do end up being a few situations where it's not quite so obvious, even for those who had it made sense in the earlier easy ones. So it's worth knowing these methods as a backup. Let's try one more. We're going to convert 21.3 pounds to ounces. So, oh yes, if you're watching the video, give this one a try. If you are in class, sure, I'll give you a minute to give it a try on your own. Okay, so on the left side, we're going to find our ratio on the formula sheet. 1 pound is the same as 16 ounces, so 1 pound to 16 ounces. And then so you see our pounds are on the left and our ounces on the right. So on the right, we're going to follow that same pattern. 21.3 pounds is to how many ounces that we're trying to find. And again, yeah, we're matching up the lefts and the rights. Turn them into fractions. 1 over 16 equals 21.3 over n. Identify the pair that doesn't have a variable. You're going to multiply those and divide by the other one, which in this case is just going to be dividing by 1. There, 340.8. And I know I keep saying it, but you might have just thought, well, obviously multiply by 16. And if you are in that category, great. Don't let me stop you. I'm not going to force you to do it my way, but I will suggest that we might run into somewhere it's not quite so obvious for you. So 21.3 pounds is equal to 340.8 ounces. Now, one drawback of method 1 is that it doesn't have, the formula sheet doesn't include every possible conversion. It doesn't say how many inches there are in a mile, for example. So you might need to go to an intermediate one first. So if you wanted to convert tablespoons to pints, look at your conversions there. It doesn't show you how many tablespoons are in a pint. It shows you how many tablespoons are in a cup, 16, and it shows you how many cups are in a pint. So you might have to go through 2 phases to get there. So convert tablespoons to cups and then convert cups to pints. So you'd have to set up one ratio for the first one, get an answer, and then one ratio for the second one, get an answer, then you have your answer. Or you might see other ways to go about that. If that's so, then that's great. For example, you might say, oh, hey, 16 tablespoons in a cup and 2 cups in a pint. That means 32 tablespoons in a pint. Now you have your own conversion factor. Super, that works as well. Let me show you a method that will handle these. It'll work in the easy situations. It'll also work when you don't have the intermediate values and you need to do a bunch of different conversions. It'll do it all in one step for you still. So let's say we want to convert 135.72 yards to feet. So we're going to start, the first couple will still be simple ones. We're going to start with the value that we're converting, 135.72 yards, and we're going to put it over 1 to make it into a fraction. And then what we're going to do is we're going to make use of our canceling that we've learned. We are going to multiply by the conversion factor so that the starting units, the units, cancel out. So 1 yard is 3 feet. So I'm going to write 3 feet over 1 yard. This method, by the way, you can apply this all over the place to any kind of conversions that you run into that you need to do, and you cancel out the units. So it's really handy. Some people do find it confusing, and if the ratio method makes sense to you and this doesn't, I would honestly just stick with the one that makes sense to you. So look what I did. I put the yards on the bottom on purpose. I could have put 1 yard over 3 feet. That would also be true because they're equal, right? So I'm just multiplying by 1 here. 3 feet and 1 yard are the same. It's like a fancy, weird looking version of multiplying by 1. But the way I wrote it there was so that the yards cancel out. And after the yards cancel out, all that's left is, I thought I circled it, but apparently not, the feet. So now I take this and I go 135.72 times 3. I don't even bother with, I wrote divided by 1 here, but obviously you don't need to divide by 1. There technically would be a divided by 1 there as well. That just helped us with the canceling of fractions. There is your conversion from yards to feet. Let's try another one. Give you a minute to try this on your own with the new method. All right, take a look at this. So I start with the thing I want to convert, 82.5 tablespoons. I find my conversion factor, 16 tablespoons in a cup. I want to cancel the tablespoons, so I put the tablespoons on the bottom. 1 cup over 16 tablespoons. Because I have now canceled out the units. Isn't this cool? Look at that. The numbers stay, but the units cancel. Once I cancel out the tablespoons, all that's left is cups, like so. And I could cancel the tablespoons because I got 1 on the top and 1 on the bottom. Now I just multiply and divide, and I'm gonna show the ones here, but you ignore them really, right? 82.5 times 1, yeah, sure. Divided by 1, yeah, sure. Divided by 16, right? And you're multiplying the top. So maybe you go 82.5 divided by 1 times 1 divided by 16. However you want to think about that, you basically end up going 82.5 divided by 16. And if you struggle to see when you should be multiplying and when you should be dividing, then both the ratio method and this canceling method just give you a process that gets it right every time, which is really nice to have. Here's the big advantage that you might occasionally run into of method 2 when the formula sheet doesn't have the conversion. We can line up those multiplications. We can line up as many as we want to and keep canceling out the units we don't want until we get the one we do want. So, for example, how many years is 1 million minutes? Any musical theater fans will know that it's going to come in at about a little under 2 years, because 525,600 minutes is 1 year. But let's actually do the calculation. 1 million minutes, we want to convert to years. Well, our conversion sheet doesn't tell us. It tells us there's 60 minutes in an hour, 24 hours in a day, 7 days in a week, 360. It doesn't tell us how many minutes are in a year. It doesn't give us the conversion factor. But we start with the one we have, 1 million minutes over 1. And, well, I can put minutes into hours by putting minutes on the bottom and hours on the top. 60 minutes is 1 hour because the minutes cancel out. Now I've converted to hours. I don't want hours, so I keep going. 24 hours in a day. I put the hours on the bottom because now the hour units cancel out. Keep going. 7 days in a week doesn't help me. 365 days in a year. 1 year is 365 days. I put the days on the bottom because now the days cancel out. So you see how handy this is. Instead of setting up 3 different ratios, you can just line these up and be very confident that you're doing the right multiplying and dividing. Now I have the units I want, years. Excuse me. So I pick up the calculator and let's see, 1 million divided by 1, I don't need to do that, times 1 divided by 60 times 1 divided by 24 times 1 divided by 365. And again, you obviously don't need to type times 1 into your calculator. 1 million divided by 60 divided by 24 divided by 365. 1.9 years. And I will say yet again, if you just instinctively, if it made sense to you that you would start dividing by those numbers till you got the one you wanted, fantastic. Go ahead. Don't feel obliged to set up something more complicated than you need. But when the ones come up that aren't so obvious, you want to have method 1 or 2 as a backup. Oh, yes. Okay, this is just a little bit of fun. Our brains, there's a lot of studies showing how our brains are very, very poorly equipped to understand numbers that are really big or really small. So while we technically know that 1 billion is more than 1 million, so if we were to convert 1 million seconds, we would find it is equal to about 12 days, 11 and a half days actually, but we'll say 12 days. Now, I don't know if you want to take a guess at how long you think 1 billion seconds is. Because most people think, oh yeah, 1 billion's bigger than 1 million. So I don't know, like 50 days, 100 days? How much bigger is 1 billion than 1 million? Well, actually, it's 32 years, 1 billion seconds. And again, as I was saying, our brains just sort of hear 1 million and 1 billion, and our primitive brain just says lots, but isn't able to clearly distinguish just exactly how much more 1 billion is than 1 million. Method number 3, I've talked about a whole bunch already. If intuitively you look at it and you understand when to divide and when to multiply, and you get all the questions right on your practice, that's great. That's great. That not everyone, most people aren't in that category, but there are definitely some that are. Yeah, I've said all the stuff. I'm not going to repeat it all there on this slide. Okay, for our last little bit here, we're going to look at converting between imperial and metric, which actually you use the same methods for. When we get to our next lesson, we will do metric conversions, and they are way easier because metric is built all around multiplying by 10, and multiplying by 10 just means moving the decimal to the left or the right. So multiplying or dividing by 10, I should say. So metric conversions are really easy, but conversions between imperial and metric, we need to use the same 3 methods that we just looked at. And these are the ones where you might, if you sort of saw, I know when to multiply, I know when to divide, these are the ones where you might be like, oh, I wasn't so sure about that one. You'll see what I mean. So here's the conversion factors on the sheet that I showed you earlier between metric and imperial. So here's an example, convert 17 meters to feet. We're going to follow the exact same method. So let's try it with method 1, ratios. Let's see, 1 foot is 0.305 meters. Great. That goes on the left. 1 foot, 0.305 meters. And then on the right, 17 feet is how many, 17 meters is how many feet. Notice again, I make sure I line up that if my feet are on the left of the ratio and my meters on the right, then it stays that way over here. Feet are on the left, meters on the right. You can reverse them, that's fine, as long as you reverse all of them. So turn them into fractions, identify the pair that does not have a variable, and multiply them and divide by the other one. So there we go, 1 times 17 divided by 0.305. And I'm going to suggest that here, this would be one where some people would say, oh, I divide by 0.305, not multiply? Yes, you do. Or if that makes sense to you just naturally, that's great. So the ratio helps us get there with absolute certainty every time. So there's our answer. 17 meters is equal to 55.74 feet. I think I do the same question with the multiplying units option. Yeah, so I start with 17 meters on the top of a fraction. I write my ratio in a way that will cancel the 1 foot is 0.305 meters. I write it in a way that will make the meters cancel because they're on the top and the bottom, which will leave behind just the feet. Now I multiply, so 17 divided by 1, I don't need to worry about, times 1 divided by 0.305. Again, the times 1 you don't need to actually type into your calculator. And I get the same answer, 55.74. Okay. Now you might have noticed that they not only said 1 foot is 0.305, but they gave you another option. They said 1 meter is 3.28 feet. If you had used this one, you would have got the same answer. You would have put 3.28 on the top and 1 on the bottom, and you would have found that you get the same result as we got before. So sometimes you can pick either one of the ratios that you want. Sometimes, though, you can't. As in this case, 520 yards to meters, there is only one option. 1 yard equals 0.914 meters. So I'm going to let you try that. Okay, trying it first with the ratio method. We're going to find our conversion factor, yards and meters. 1 yard equals 0.914 meters. That ratio goes on the left. Now we have 520 yards and unknown meters, so that ratio goes over here, making sure that we line up the units. So we have yards to meters on the left and yards to meters on the right. The rest we can breeze through, turn them into fractions, multiply the pair that doesn't have a variable and divide by the other one. 0.914 times 520 divided by 1. 475.28 meters. So 520 yards is 475 meters. You can see yards and meters are very close to each other for short amounts, like just 5, 10, 15 yards, meters are almost the same. You can barely tell the difference. But once you get up into the hundreds, you start to be able to distinguish between the distances. And let's do it with the canceling units method. So I start with the thing I'm given, 520 yards, right? Start with that as a fraction on the left, or not even on the left, sorry, we're just multiplying. And 1 yard and 0.914 meters are multiplied in a way that the yards will cancel. I'm going to pause and I'm going to throw one thing in here because I want you to notice here, we've been doing a lot of cross multiplying. We're using the cross product. You will notice I am not using the cross product for these ones with method 2. Why am I not using the cross product? Because this is not an equal sign. Remember, we said that over and over and over in our proportion lessons. The cross product is a very special thing that helps us when we have one fraction is equal to another fraction. That's not what we have here. Here I am multiplying two fractions. Do not use the cross product. It will give you the wrong answer. So 520 times 0.914, and of course, again, we don't need to divide by 1, but if there was a different value there, we would divide by it. And we get the same answer, 475.28 meters.